there, children. Today, we are going to work on the Chapter 7 Common Assessment Review. This educational experience is brought to you by me, because hooray for that. Alright, so this first problem here, we've got 4 times u to the negative first, v to the fourth, divided by u to the 5/4, v to the 2/3. Okay, in this problem, we are going to utilize my quotient property, which says I just do the following. The 4 is going to stay the same. Then I'm going to take my u, numerator, minus denominator. Now, you could move this down and add them. That's also something you could do, but I'm going to use this particular property because it's one of our properties we learned about. And then v to the 4 minus 2/3. Now, when you do this, 1 minus 5/4, you need a common denominator there. That's going to get you a 4 u to the negative 9/4. V, 4 minus 2/3 is 10/3. If you don't believe me, do a little side work here, and you're able to see that. This would become 12/3. Because I need a common denominator, that becomes 10/3. Is the problem done? No, 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 no. It's not, because the direction said, hey, I must only contain positive exponents. And that's not positive. So what I'm going to do is I'm going to keep the 4 and the v to the 10/3 up top, because they don't move because they're not negative. And when something's sad or negative, you move it to the basement or the opposite side of the fraction, and it becomes positive. Done deal. Oh, happy days are here again. Moving on. This particular problem, let's look at combining our like terms here. Now, our like terms in this problem being the following. I have a 2 and a 4. Remember, you multiply your coefficients, that's going to give you 8. Then, you're going to look at our x's. Do I have any friends? Yep. X to the negative 5/3, x to the first. So then I add those. I get x to the negative 5/3 plus 1. And then y. What I'm going to go with y here. If I look, I'm going to go y squared, y to the negative second. So that's negative 2 plus 2. Now, that's going to become a 0. And y to the 0 power is going to be 1. So there, I've got that going for me. Now I get this, when you add that up, x to the negative 2/3, you need a common denominator there. Guess what? Not okay to have a negative, so I've got to switch that around, and it's got to become positive when I flip it down to the basement. Okay, oh happy days are here again. Let's continue to the next problem, shall we? Yes, indeed. Okay, this problem's a little trickier, because I have a power to a power, and when I have that power to a power, I'm going to multiply, because sharing is caring. Very good, imaginary voice in my head. So, we're going to go ahead and do this. 3 halves there, and this is going to multiply and get me a negative 3. 3 halves times a negative 2, the 2's would cancel. Over here, again, more sharing, more caring. Distribute the 2 in there, because that's what I need to do. Boom, boom. That gets me x squared, y to the 4/3. Now I go back to my wondrous and glorious idea of adding my like terms up. Adding their exponents. I have a y to the 4/3 and a y to the 3 halves. Now I know what you're saying. Oh no, they don't have a common denominator. You are correct. They don't right now. But don't you worry, child. We're going to figure this out. That's going to give me a 9/6. And this is going to give me an 8/6. How do I get that? Multiply this one by 2. Multiply that one by 3. And lo and behold, I get 17/6. That is going to be my y value there. 17/6. Now, I look back to my x's. Alright, x's, I have x to the negative 3 plus 2. That's an x to the negative first. Well, guess what? Oopsie daisies, not allowed to have that. So I get y to the 17/6 over x. What? That's right. I have to flip that again because it needs to become a wonderful and glorious positive number. Moving on. Alright, now to the problem which bothered people the most, it seemed like. So the first thing I'm going to do is, using my exponent properties, I'm going to split these up into two different things. I'm allowed to do that. So when I get this, that's going to give me a 4 up top and a cube root of 9 on the bottom. Because the cube root of 64, what to the third power gets to be 64? That's 4. That's one of the ones you have to know. And the problem is, I can't have radicals in my denominator. Yikes! But what I can do is, look, this is 3 squared. If I get one more 3 introduced in there, I can pay the evil troll toll, and it can leave my exponent. So guess what I'm going to give it on top and bottom? A cube root of 3. So you have to ask yourself, and let's just think about this for a second. I've got to ask myself here, what in the world is this? This is 3 squared. If I introduced one more 3, the index would match the exponent, and that number could walk on out free as a whole number. Or if you want to think it this way, it needs to get one more 3 up top there in this problem to pay the evil troll out here to leave the radical. So when I do this, this top becomes 4 cube root of 3, whoop-de-doo. This bottom becomes the cube root of 27, which, as we just talked about, is 3 to the third. Oh, look at that. It can pay the troll toll and walk on out. Now it's simplified down because now at least the bottom part's a whole number. That's what I was going for there. Moving on. This particular problem again, my troll is 4 there, so I need to break things up into things to the 4th power. Let's take a gander here. So 81, that's really 3 to the 4th power. J to the 10th, I can break that down as j to the 4th, j to the 4th, j squared. T to the 10th. T to the 10th I can break down, extend this line a little bit, as t squared, t to the 4th, t to the 4th. Let's see if we can leave my troll here. These two t's can walk on out. They pay their exponents as they leave. What other t is stuck under there? Why, guess what? T squared is stuck under there. It can't leave because it does not have enough to pay my index out there. So, sorry t squared, you're stuck. Let's look at these. Alright, these two j's can walk on out. What other j is stuck? That one's stuck under there. Doesn't have enough to pay the troll. That 3 to the 4th. That can leave as a 3. Now, remember, the exponents go away when they leave here. That's very, very important. It doesn't get to walk out without paying a toll. So this is 3, j squared, t squared, and you simplify. Don't forget to write your index here. Problem solved. Moving on. Alright, we can't add these at first together, so I'm going to simplify them down as far as I can. The square root of 50 is square root of 2 times the square root of 25. Square root of 72 is the square root of 32 times root 2. Now, why did I break it down this far? Why did I do like 5 and 10? Easy. These break down to perfect squares. This is 5 root 2 plus 6 root 2. And now look. Same radical, you add their coefficients, you get 11 root 2. You must simplify these down as far as possible. Moving on. This problem not as bad as you think. Look, these two are like terms. It means I subtract their coefficients. And if you, in case you forgot, guess what? There's a coefficient of 1 out in front here. Now the thing you cannot do is you can't go, the answer is 6 here. Oh look, those things cancel out. No, they don't. I have 7 of something, I take 1 of that something away, I am going to be left with, drum roll please, 6 of that something. That's all I'm going to be left with. The somethings don't go away. They don't get added together. You don't get something squared. So, there you go. Moving on. Okay, this particular problem, I take to the 2/3 power. Why do I take it to the 2/3 power right away? Because the radical is isolated. There is nothing behind it or in front of it that I have to subtract. When I do that, the gooey nougaty center is going to fall out, giving me 2x plus 20. 512 to the 2/3 is 64. Now, do I need a plus or minus? Absolutely not. Why? Because the thing I started with was a 3/2, which, by the way, is an odd number because my numerator is odd. When it's an odd number, I don't, in fact, need to do that. Oh, happy days are here again. Now I'm going to divide by 2 here. Yay for that. And when I get done with this problem, you will realize, lo and behold, x equals 22. Now, I'm going to check that answer, putting it in. That works in the original problem. Always check your answers, folks. You have time to do so. Moving on. The first thing I do here, folks, is divide by 2. Why do I divide by 2 for number 9? Well, you have to remember that there is something out in front of the radical. So before I do anything else, I must divide by 2. Now, I get 4 here as my exponent. Now, what's the reciprocal of that I should be taking both sides to? Well, that's the 1/4. And lo and behold, the thing I started with, as you recall, is an even number. Therefore, when I do my work here, I'm going to get x minus 3. This is going to be 3 over here, but a plus or minus comes out in front, which means I need 2 equations. Now, you're wondering, why in the world does a plus minus come out? Remember, the exponent I started with is an even number. So here I'm going to get 6, and here I'm going to get 0. How did I get those things? Well, I add 3 to both sides. It just gets me different answers. You go ahead and check those answers in the problem, and lo and behold, it works. Oh, happy days are here again. Moving on. This problem, what I'm going to do is I'm going to square both sides. Now, when I square both sides, you're asking, why am I doing that? I need to undo a square root. Now, the pitfall everyone makes when they square both sides is the following. Oh, this is just going to be squared, no big deal. That's going to be n squared plus 4. No, it's not. Just a quick little workaround over here. That's n minus 2. N minus 2, you're going to have to FOIL. And when you FOIL this item, you get this. Now, there is an n squared minus or plus 4 in there. That's absolutely correct. But guess what? You're missing the gooey, nougaty center of FOIL when you do that. Do not forget to FOIL things. Now, what do I do from here? Over here, the square root goes away. All right, I've got to square my problem right there. When I do that, I've got to set it equal to 0. Why do I set it equal to 0? It's now a quadratic, folks. When I have a quadratic, I must set all quadratics equal to 0. You're wondering how I get that? I add 20 to both sides, and I subtract 7n. I like keeping the n squared positive, so I'm not going to move that one around. Now, this is a simple factoring problem. 2 numbers that multiply to 24 but add to negative 11. That's going to get me a negative 8 and a negative 3. If you don't believe me, guess what you can do? When in doubt, you FOIL it out. Very good. And there we go. Now we're going to check both our answers. You can do that while I'm finishing to write these off. Why, yes, both of them do work. Oh, happy days are here again. Problem solved. Moving on. All right, this problem, you're going to square both sides. As such, when you square both sides of the problem, that's going to get me this. 25 minus 2v equals v minus 2. Okay, I'm going to do a couple things. I'm going to bring all my variables to one side. I'm going to bring them, well, to the right. Why? Because I can. And then bring the constant numbers to the left. Why? Because I feel like it. It doesn't really matter, does it, which one you do. The choice is yours and yours alone. Kudos for that. I get 27 equals 3v. Why, I'm gonna divide by a negative, or divide by a 3, not a negative 3, excuse me. Divide by a 3. That's gonna get me v equal to 9. That's a correct answer. I can check that and figure out that it works. Moving on. Okay, g of x minus h of x. Literally all you do here, folks, is you take the g function and you subtract the h function from it. Now, the important point is put these in parentheses. Why do I do that? Because, guess what? The negative gets distributed to both those terms, making it a plus 2. And then you play the game of, I want to combine my like terms. Good for you, buddy. And I combine my like terms. Boom, boom. There's the answer I get. It's a plus in the middle. Oh, happy days are here again. Distribute the negative is very key there. Moving on. This problem you FOIL, folks. You FOIL this problem. That means first, I get x to the 4th. Why is it FOILing? It's multiplication. Then the outside ones, you get negative 4x to the 3rd. I think you know where this is going by now. Inside, I get negative 4x. And last but certainly not least in our pantheon of FOILage, that would be a positive 16. I combine my like terms. Well, guess what? There aren't any. So there is my answer. Moving on. Alright, this is one of those composition of function problems. Remember, it's h of g of x, which is this. You have to remember that notation. Now, what that means is every time that you see the h function, which is this, and you see the letter x, you go, no, no, it's not going to be an x anymore. It's going to be a g of x. Because I'm putting g of x into h. And you're wondering, well, what the heck is g of x? Luckily, I know that in this problem. It is x squared plus 5x. And guess what? It's 3x squared plus 15x. And then plus that 4. Nothing can combine. So I'm done and I move on. Okay, for this graphing problem, remember, the original 2 points for a square root are these two things. 0, 0, and 1, 1. Well, what do these transformations do to my graph? This transformation makes it go up 5 units. And the other transformation, remember, opposite on the inside. That's not the first time you've heard me say that this year. Instead of going negative, I'm going to go to the right 4 units. So we take our points and we go, all right, what was at 0, 0? Now goes over 4, up 5, plot it. Then what was at 1, 1 goes over 4, up 5, plot it. And then you draw your nice smooth ray. I want these points labeled, so you've got to label that. That's 4, 5. And that then is 5, 6. And now you move on to the next problem. The next problem, for instance, is a cube root. Now the cube root, you have these 3 key points that you've got to move around. That should be a review for everybody. Well, this whole thing is review, but that's notwithstanding. Okay, now what are these transformations doing to my graph here? This one goes down 1. This one goes, because negative it goes down. This one again goes to the right 4 units, so let's look at my graph here. What was at negative 1, 1? Now is going to go where? It's going to go over 4 and down 1. Boom. That's at 3, negative 2. What was at 0, 0? Over 4, down 1. That's going to go at 4, negative 1. And what was at 1, 1 is going to go over to 5, down. That's at 5, 0. And now remember, this is a nice smooth curve like this. And by the way, that's 5, 0 there. Points must be labeled. Big so I can see them. Boom, boom, and boom. Alright, moving on. The directions for this problem say find the inverse. Okay, remember, h of x is the same thing as saying y. That's a review. So the first thing I do is switch x and y, and then solve for y. There's nothing really that earth-shattering there. I'm going to subtract 4 from both sides and divide by negative 2. I'm allowed to do that to get y by itself again. So I subtract the 4, then I divide by the negative 2, And that's going to get me what the inverse is. Now remember, our inverse notation is h to the negative first power of x. You could have this, or if you felt so inclined to be fancy, you could divide out the negative to both terms and get the following. Both are mathematically correct and would be accepted. So all I did here was divide negative 2 to x, getting negative 1/2 x. Negative 4 divided by negative 2 is 2. Moving on. This problem asks you to verify if they are inverses. The first thing I have to check is h of f of x equals x. Remember, the two things need to hold true. You need to put one function into the other one and then reverse the order. And if you put it in x, you better get back in x. They both have to equal x. So what I'm going to do here is I'm going to put f into h. So I take my h function, which is 1 over 5. Instead of it, that, I'm going to put f of x. Instead of that x there, I'm putting f of x. Now, it shouldn't be a plus minus there. That will be a wonderful and glorious, the plus sign. So let's fix that a little bit, because that'll become very important here in a second. Now what I do is I put in whatever I thought that f of x was. What do I know f of x is? Oh, it's right there in the problem. So, oh happy days are here again. I distribute the 1/5, and I get 4/5 x plus 12 over 5 plus 4. Now, that shouldn't be a plus minus there again, but I have a question for myself, I guess, in this case. Is there any way this is going to be able to equal x? No, is the answer to that question. There is no way I'm going to be able to reduce this thing down to equal x. Not able to happen, so they are not inverses. I can't get this to equal x because there's no way that 4/5 x is reducing down to an x because there's nothing else for it to combine with. So not inverses. Now, because of that, I don't even have to check this one. If this did equal x, I would have to check the other combination to see that it worked. But this one doesn't, so I can stop. This is a non-calculator section, so put those calculators away. The first thing here, it said, hey, turn this into exponential form. Well, guess what? The index, that index number is always going to be what? The index is always going to be my denominator of my fraction. Now, guess what? It's very important here you do the following. You put this in parentheses. If you don't put it in parentheses, it is incorrect. Let me say that again. If you do not put this in parentheses at 5x, 10x to the 5/6 power, it's wrong. So, this is not correct. Just so we're clear, because you are not sharing the exponent to both items. This is wrong. No. No, no, no. No. Sad face emoji. Moving on. You're asked to turn this into a radical, so put a radical there. No radical, no points. What's under the radical? The stuff that's under the exponent. Okay, cool. Guess what? What power does this go to? 1. It goes to the first power. Okay, whoop-de-doo. The numerator is always the power of the inside stuff. The denominator is always your index. Done deal. Moving on. The next set of problems are a little trickier. They ask you to do this without a calculator. I don't want you to whine and complain about it. Here, it's exponential form. You don't like that? Turn it into a radical. So that's a radical. What's the index? 2. What's the base? 4. The whole thing is to the third power. Or, this is what you have, 4 to the 1/2 to the third. Well, guess what? What's the square root of 4? Think about that for a second. It's 2. 2 to the third. This will get you 2 to the third. What's 2 to the third? 8. That can be done without a calculator. Now, the next one's already in radical form for you. The question I have is what to the third power, because that's my index, gets me 125? Well, think about that for a second. Let's ponder. Guess what? What to the third power gets me 125? Why, that is 5. The 5 can pay the evil troll and leave. You are now ready to tackle your Chapter 7 assessment. Go henceforth and do. Commence.